Welcome back. This time we're going to go into deep learning and model training on AWS. Before we do, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, deep learning represents a fundamental shift in how machines learn from data. Unlike classical machine learning, deep learning uses artificial neural networks with many layers to process unstructured data like images, audio, text, and time series inputs. Understanding how to train, tune, and evaluate these models within the SageMaker ecosystem is central to working with AWS machine learning services. So, understanding the deep learning architectures. I went too far back. No worries. Okay. So there's three primal neural network architectures that dominate deep learning applications. Convolutional neural networks, CNNs, excel at image recognition by extracting spatial features through convolutional layers. Recurrent neural networks, RNNs, handle sequential data like time series by maintaining memory of prior inputs. Transformers use parallelized attention attention mechanisms for natural language processing tasks. AWS provides managed services and pre-built algorithms for all three architectures. So the three stages, all right? Model development follows a clear progression through training, tuning, and evaluation. The first one is training. This is where your model learns from data. Deep learning training passes inputs through multiple neural network layers and adjusts weights using backpropagation. SageMaker lets you use built-in algorithms, bring your own containerized models, or train in distributed mode using multiple GPUs or Spot instances. Next would be tuning. This tuning optimizes hyperparameters that aren't learned during training. Learning rate, batch size, number of layers, and similar configuration values. Poor tuning leads to overfitting, where the model memorizes training data, or underfitting, where it fails to learn meaningful patterns. SageMaker's automatic model tuning uses Bayesian optimization to test different hyperparameter combinations in parallel. And then you have evaluation. So this measures the model performance using appropriate metrics. Use accuracy for balanced data sets, precision when you care about correct positives, like fraud detection, and recall when you need to catch all actual positives, like disease detection. F1 score for the harmonic mean of precision and recall. Confusion matrices for detailed breakdowns, and ROC curves with AUC for true false positive trade-offs. So some SageMaker services for deep learning. There's 4 key SageMaker services that support deep learning workflows. First one, SageMaker Autopilot. This automatically builds, tunes, and evaluates models. It converts raw data into fully trained models using best practices, supports explainability, and generates multiple candidate models for comparison. Okay, next would be SageMaker Experiments. This organizes and tracks training runs with their associated metadata, parameters, and metrics. This systemic approach helps you compare different models and configurations objectively. And then you have SageMaker Debugger. This monitors training jobs in real time, identifying issues like vanishing gradients, overfitting, or stalled training before they waste significant compute resources. One more. TensorBoard. So TensorBoard integration. This visualizes training metrics in real time within AWS, providing transparency into your deep learning model's behavior during training. My apologies for that. So let's go over to the console and go to, see the S3 bucket, under training jobs. We'll click create training job. All right. Deep learning test. All right. Your source will be an S3 bucket typically for your input source, your output source, and your checkpoints. Excuse me. Choose the appropriate IAM role, built-in algorithm, and let's see. What am I saying? Well, you can also bring your own one in. I am not seeing object detection. You could really choose any one of these, but which one haven't we gone over? I think we've gone over all of them. All right, so we'll just choose a random cut for us. All right, here you'll see the CloudWatch metrics. You can choose the input mode, pipe from the S3 file, downloads locally, and then goes on down to the actual pipeline. All right, then you'll select your instance type. Since it's going to be deep learning, you're going to do ml.p and choose one of these. We'll stick with the p3.8x large. You can go a little smaller, but it's good for most deep learning tasks. You specify the number of instances. Say you can use multiple ones for distributed training on large data sets, though this can add complexity. All right, but let's just say 2. And then instance count. Oh, I'm sorry, that was the volumes. Let's do 50 gigabytes. Let's say 2 instances. Keep alive is 60 minutes. Encryption, we're not going to need encryption because we're just testing this, but when you get to production, you will. Network isolation, that's an option. With your VPC, we only have the default set up here. Okay, and then we're going to do the parameters. All right, so you want SageMaker to find the parameters. So let's see. You want to set, let's say your number tree to 100. That's good. 256, your feature. 0, 1. Okay. And how do you want to set this for accuracy, precision, or recall? F-score, accuracy. Yeah, that's a good one. All right, then you're going to set your input mode. I think we set it at pipe up top. Content type, one of these ones. Let's say text CSV. All right. No wrapper, no compression. S3 right here. Checkpoint if you're going to use your spot training. All right, the out point here, your key value pairs for tags, and then you click create job, right? Once you submit it, you can monitor this through CloudWatch logs or within the SageMaker Studio. And you can watch for convergence in your training metrics and check that the validation metrics improve alongside your training metrics to avoid overfitting. Okay, we'll cancel that. Okay, so next would be pricing. So deep learning training is computationally expensive. GPUs provide the acceleration needed for CNNs and RNNs, but cost a lot more than CPUs, right? Or CPU instances. EC2 Spot instances, which we just pointed to about with the checkpoints, that can reduce training costs by 50 to 90% with minimal configuration changes. And SageMaker can charge per second for managed training jobs based on instance time, storage, and logging, right? So you'll use that ml.p or a higher instance for CNN and RNN models. And you could use SageMaker savings plans or spot training for cost efficiency on longer training jobs that can tolerate interruptions. All right. And then let's see, practically. All right. So these are some of the managed ways that you can go about with the training. All right. But one thing that I've seen is a typical deep learning workflow could involve something like a convolutional neural network on an image data set like MNIST, right? So you could start by evaluating baseline metrics like accuracy and precision on your validation data set. You can apply regularization techniques like dropout to prevent overfitting. You could tune those hyperparameters, including like the batch size, the number of epochs, the learning rate, to optimize performance. So that would give you a model to understand how hyperparameter choices affect training dynamics and final model quality. How does this integrate with AWS? One, S3 that stores your training data and your model artifacts. CloudWatch will capture the logs, metrics. The SageMaker pipelines can automate retraining workflows when new data arrives. And then SageMaker model registry versions trained models for governance and deployment management. So for production deployment, SageMaker endpoints can host your trained models for real-time inference, while batch transformations can handle large-scale offline predictions. A couple of points for the exam. Deep learning uses multi-layer neural networks for unstructured data. CNNs handle images, RNNs handle sequences, transformers handle text. Training adjusts model weights through backpropagation. Tuning optimizes hyperparameters not learned during training. Evaluation uses metrics appropriate to your problem. Think accuracy, precision, recall, F1, and AUC. SageMaker Autopilot can automate the full training pipeline. SageMaker Experiments can track runs for comparison. SageMaker Debugger can identify training issues in real time. GPUs are essential for deep learning, but do have costs, and then costs can be reduced with spot instances, and you must be able to tolerate interruptible loads. So when the exam is asking about neural networks, optimizing model performance, or handling unstructured data like images and text, deep learning with SageMaker's managed services is your answer. Anyways, that'll be all our time today. Thank you for joining, but remember to hit the like, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.